Assalamu alaikum everyone. How are you guys? Walaikum salam. I'm good, alhamdulillah. Thank you. Walaikum assalam. Walaikum salam. Depressed after AdMath mid today. Acha, how bad was it? I'm good, alhamdulillah. Thank you for asking. Midterm exams are important, but a bad grade in a bad grade in mid-year exam is not the end of the world. I should mention that. Yes, I know midterm exams are coming up, so inshallah I'll be streaming a lot more frequently. I will be covering, so you might have noticed that I'm starting with some easy topics. I'll be doing some more difficult topics also inshallah very soon, such as mensuration, trigonometry, statistics and all that. So let's see. Didn't get a single final answer, left everything at working. Ooh, acha, that's okay. That is not a good situation to be in, but the good news is you have a lot of time. Make sure that you make good use of it. That's what I would say. But it's not the end of the world, okay? Screwing up in midterm is fine. I mean, if you do well, it's a bonus. You are motivated to do even better. But if you don't, then you can use that also as motivation. You know, it all depends how you look at it. You can use that as motivation and do better in mocks, and then finally inshallah in your CIE exams, inshallah. Math exam Tuesday. Yeah, I know you guys are all having your exams sooner or later. So anyway, let's get to work, shall we? Okay, what perfect timing. I have a math P1 mid tomorrow, and I hope this helps. Tomorrow is Saturday, so you have your exam tomorrow. Okay, that's cool. Anyway, so let's start. We are starting with indices. Now, indices is tested in paper 1. Okay, so as far as O levels is concerned, you will mostly find this in paper 1. Okay, that doesn't mean that it can't come in paper 2, but even if it comes in paper 2, it will be very much like a paper 1 question, meaning that it's going to be a non-calculator question. Okay, so if you have if it's tested in IGCSE, make sure you guys know your syllabus codes really well. I still see people getting confused over it, so make sure that you guys know your syllabus codes really well. This is for O level math. Okay, मैंने अभी कुछ टाइम पहले वीडियो बनाई कि IGCSE मैथ पेपर 2 में कैलकुलेटर अलाउड नहीं है, and people started saying कि oh no, it's always been allowed, and it's in paper 1 that calculator is not allowed. So turns out that they were confusing it with O level math. Okay, so make sure that you guys are clear about what subject it is that you're preparing for. You know the subject code also really well. Okay, so what's important is that both of them are non-calculator. Okay, both of them are non-calculator, and the amount of marks can vary. Okay, you can expect a question somewhere in between. Could be a 5-mark question, could be, it's usually 5 marks. Okay, so it's usually 5 marks. Okay, but 5 very easy marks. Now I know 5 marks is not a lot, but it's a lot when you can get 5 marks very easily without doing without doing a lot of working. Okay, but still people tend to mess it up because they don't do the step-by-step procedure, they don't follow instructions. That's why people still mess it up. Okay. Sir, आपने तो गंज बेटा मैं उम्र करके आया हूँ. It's been a month, so that's why. Anyway, today's date is the 29th of November 2024. So as you can see, you guys can probably tell, from the name of the stream that this is concepts as and past papers. So I will cover all the rules, okay? But the thing about indices is you can cover all the rules multiple times, but for as long as you don't start past paper questions, you wouldn't know what you wouldn't basically feel prepared, okay? Because when you're doing past paper questions, all the rules, all the concepts are tested at once, and that is when you're really able to polish your skills, okay? So when two bases are multiplied and the bases are same, what happens to the powers? The powers are added. And I should mention before I start that you guys should know what a base is and what a power is. So let's drag this here. Let's say that you have something like this. You have a power m. So a is the base and m is the power. I'm sure that's something that you guys might know already, but let's write it down anyway. A is the base and m is something that's called the power. Not just the power, we also call it the exponent. We also call it index. That's where indices comes from. It's the plural of index. And it's also called, not a lot of people know this, it's also called order, okay? In fact, the O in BODMAS basically stands for order, okay? But hey, that's a different story. So it's kind of irrelevant right now. But same bases, when same bases are being multiplied, what happens to the power is that the powers are added, okay? How long will this stream take? This will probably take 2 hours, okay, at max. Now with every rule, I'm going to do an example. So let's say that you have x cubed, which is being multiplied by x power 5. So what will happen as a result is that we'll add the powers and we'll have x power 8 as our answer, okay? If let's say we have the same can be applied to numbers also. If let's say you have 3 power 5, which is being multiplied by 3 square, so we can simplify and rewrite this as 3 power 2, okay? Yeah, I'll do complex topics, don't worry, I'll do complex topics. So I'm starting with some easy ones and then gradually I will move towards complex ones as well, such as mensuration and trigonometry, okay? If you have any suggestion, please do let me know on my Instagram. Okay, so same bases are being multiplied, powers are added. So that means what happens if they're being divided? Well, in that case, powers are subtracted, okay? Let's do some examples. Let's say that you have x power 8, which is divided by x power 2. So we can simplify and write this as x power 6, okay? Part B, let's say that you have 4 power 5, which is being divided by 4 cubed. Now, we can evaluate this, but then we would have to figure out what 4 power 5 is and then figure out what 4 cube is. So instead, what we'll do is we'll take the easy way out. We'll use the indices rule. Same bases are being divided, so we'll subtract the powers. And we have 4 squared, which we can evaluate very easily, is equal to 16. Okay, so there you go. That is the answer. Now, I would like to add an example over here. Let's say you have x power 3, which is being divided by x power 7. Okay, now you could do this 2 ways. You could do this the usual way, which is that this can be written as x raised to the power 3 minus 7, which means x raised to the power minus 4. Or you can do it like this. Let the denominator be where it is, okay, and you take the numerator down, and this will be 1 upon x raised to the power 7 minus 3, which is equal to 1 upon x power 4. And this is something that we're going to learn through a rule anyway, but just so you guys know that you can do this question this way as well. Okay, so let me drag this here. There you go. Okay, now next rule. So I'm going to read a few comments now, sir. I think I've answered that. How many times should I do topicals before 2025 exams? There's no magic number. There's no magic number as far as the number of past papers you need to do. There's no magic number as far as the number of hours you need to put in. हाँ, एक bare minimum ज़रूर होना चाहिए. But it all depends on how well prepared you're feeling. If, let's say, after doing 5 years of topical past papers, you feel like you're prepared, and every time you look at a question, it's a piece of cake, it's not challenging you anymore, then I think that's enough. You can now focus on other subjects, other topics. But if, let's say, even after solving 10 years of past papers, you're still getting stuck, or you're still not doing as well as you would like in the 11th year, then obviously you need to maybe reevaluate your understanding of the concepts and focus on that first before you try and pile up the number of past papers you need to solve. Okay? Now, rule number 3. If, let's say, you have, so far we've been looking at same bases but different powers, but what if you have different bases but same powers and they're being multiplied? Now what do? We multiply the bases and we raise them to a common power. For example, let's say you have 2 cubed multiplied by 5 cubed. So I can always do 2 cubed, I can figure out what 2 cubed is, I can figure out what 5 cubed is, multiply them, write the answer. But instead, I would prefer to simply multiply 2 and 5 and then cube the whole thing. So 2 into 5 is 10, 10 cubed, let's see what's that, that's equal to 1000. Okay, yes, this stream will be posted later. Inshallah, Sarah, I am going to do that on Monday. Yeah, most likely on Monday. I was supposed to do it on Wednesday, I guess, but I'm sure you guys are aware of what happened in Pakistan, what the internet situation was like, but it's resolved for now. So hopefully I'll do it, inshallah, on Monday. Okay. Now let's say you have 4 squared, which is being multiplied by 5 squared. Once again, same powers but different bases, so we can always multiply the bases and raise the result to the common power. So 4 times 5 is 20. 20 squared, we all can evaluate 20 squared, that's equal to 400. Okay, let's do one more rule. 3 or 3 6 nahi hoga. No, you don't multiply the powers. You don't add or multiply the powers when bases are same. When powers are same, you simply multiply the bases. Okay. No, powers nahi hongi plus. When bases are same, when powers are same, sorry, I keep mixing it up. When powers are same and bases are different, just the bases get multiplied, power remains as it is. Now the same principle can also be extended to division. That is, if you have different bases but the powers are same, you can simply multiply, you can simply divide the bases and once again raise them to a common power. Okay. So for example, let's say you have 10 cubed divided by 5 cubed. Now we can always do 10 cubed divided by 5 cubed using their actual values, but instead let's do 10 upon 5 first and then cube the whole thing. So 10 upon 5 is 2, 2 cubed, which is equal to what? Which is equal to 8. अगर powers different होंगी तो कोई rule ही apply नहीं होगा. ठीक है? Whatever rule that we're doing, apply, don't just apply every single time. There are some conditions that must be fulfilled for the rule to be applied. Okay? Sir, can you do more S1 topical files? I have covered permutation. I will start combination, inshallah, from the coming month. But I have covered all of permutation. No, I don't have S1, as many S1 streams as I would like. But I'm working on them. Inshallah, by the end of this session, my target is to do all of S1 and all of M1. And hopefully P3 also. Okay. All right, now rule number 5, perhaps the easiest rule, anything raised to the power of 0 is 1, given that a is not equal to 0. Okay, 0 raised to the power of 0 is not 1, so be careful about that, it's an error. Okay. Another very important and very easy rule, and that is no matter what you raise 1 to the power of, that's always going to be 1. Okay, 1 raised to any power is always going to be 1. Why? Because no matter how many times you multiply 1 by itself, it just remains 1. Okay. All right, rule number 7. Rule number 7 is that if you have a power m, which is the whole thing raised to the power of n, then what happens is the powers get multiplied. So a power m into n. Okay, and by the way, we can also swap the powers. Okay, because they're being multiplied. So as far as multiplication is concerned, even if, let's say, you swap the order, it's still the same thing. Now, what do I mean by that? Here's what I mean. Let's say, so this is an example on the side. Pay close attention. Let's say you have 2 squared, which is being cubed. This can also be written as 2 cubed being squared, and irrespective of how you write it, it's basically 2 power of 6. Okay, irrespective of how you write it, it's basically 2 to the power of 6. All right. Just a minute. Just a second. Yeah. Okay, did I miss anything, sir? Do you really like maths as much? I like teaching maths. I like teaching anything that I can teach. Doesn't have to be math. Okay, so let's do some actual examples of this rule. So let's say that you have the following. Let's say you have x squared or x cubed, y squared, and the whole thing is being cubed. So what happens as a result? The power 3 gets multiplied by 3. The power on y also gets multiplied by 3, which means x raised to the power of 9, y raised to the power of 6. Okay? All right, let's do another example. Let's say you have x squared y cubed upon 3xy, the whole thing square. Okay, so I've mixed up a couple of rules. So here's what we're going to do. First of all, let's simplify inside the bracket. So there's no constant. Okay, so it's going to be 1 upon 3 as far as the constants are concerned. So I'll just write 3 in the denominator. Then as far as x squared and x is concerned, using rules of indices, it's going to be x raised to the power 2 minus 1. So it's going to be x in the numerator. Then once again, using rules of indices, we will simplify y cube upon y. I just gave away the answer. That's going to be y squared. And then do not forget that you still have to cube the whole thing. Okay. So x square, I think I said cube. I meant you have to square the whole thing. Okay. So x square becomes x squared. Y square becomes y power 4. And don't forget that you have to square 3, which is going to be 9. Okay. So there you go. That's the answer to part B. We will do lots of past paper questions. By the way, I don't know if I mentioned, you guys can download the past paper worksheet. There are 2 worksheets, one calculator and one non-calculator. There will be a link in the description. Make sure that you guys download those worksheets. I will be solving those worksheets today, inshallah. Okay, explain again. All right, I'll go over it again one more time. So we simplify inside the bracket. So it's 1 upon 3. That means we cannot simplify this 3 any further. X squared upon x can be simplified and we get x power 1 because of rules of indices. Y cube upon y becomes y squared, and now we still have to square it. So once we square it, x squared becomes x squared, y squared becomes y power 4, 3 squared becomes 9. Okay, it's a step-by-step procedure. Please don't try and think that you can get to the final answer, because if you do that, you'll get it wrong and then you'll blame math. The problem is not math, the problem is you. The problem is that you're trying to be over smart, and that's why you're messing it up. Okay? All right, so when you have a power that's negative and you wish to make it positive, you simply take the reciprocal. Okay? You take the reciprocal of the base. So for example, if let's say you have a power minus 2, if you wish to make this positive, this is going to be 1 upon a squared. If let's say you have a power minus 2 upon 3 and you wish to make the power positive, that is 1 upon a raised to the power 2 upon 3. Reason why I'm doing this example is because a lot of times people think that they have to take the reciprocal of the power also. They don't have to do that. It's you just need to take the reciprocal of the base. Okay, so let's do some examples so that we can make sense of this. Yes, I will upload this. I'll upload the notes. The worksheet I've already uploaded. Now, questions like these usually come with the following statement, and that is evaluate. Okay, so let's say that you're asked to evaluate 2 power minus 3. Now, this is a no-brainer. This will become 1 upon 2 cube, which is equal to 1 upon 8. Pretty simple. Let's say that you have to evaluate 3 upon 2 raised to the power of minus 2. Okay. Now, you cannot evaluate power minus 2 while the power is minus 2. So, you will first make it positive. How will you make it positive? You will make it positive by taking the reciprocal of whatever it is that's being raised to the negative power. So what is being raised to the negative power? This entire fraction. So that means you need to take the reciprocal of the entire fraction. So 2 squared is 4 and 3 squared is 9. There you go. Yes, I will do a stream on mensuration, inshallah, most likely coming week. Coming week, I will most likely do a stream on mensuration, inshallah. Mensuration, trigonometry, statistics. I plan to cover all the important paper 2 topics very soon. Okay, who can tell me the answer to this? 1 upon 2 raised to the power minus 2. See if you can give me the answer to this, and see if you can give me the answer to this. 4/9. Okay, that's correct. Good job. So mensuration, statistics, trigonometry. What else? What about everyday math? Two power 2, which is equal to 4. That's correct. So this becomes 2 squared, which is equal to 4. Good job. Simultaneous equations involving indices. I can, but it's not tested in math. That's something that's tested in ad maths. It's not tested in math anymore. I mean, not anymore. It was never tested in math. 24. 24 is the correct answer. Good job. So here's how this works. 3 remains as it is. Okay. Since it's 2 that has the negative power, that means we will only take the reciprocal of 2. Okay. So 2 raised to the power of 3. 2 cube is 8. 8 times 3 is 24. Good job. Good job, fellas. Exponential growth and surge. Ayan, I think you didn't join when I was streaming exponential growth and surge. Okay, I'm done with exponential growth and surge, and there was something else I covered with that. Yeah, recurring decimal to fraction. Okay, I've already done a stream on that, so please make sure to check it out. Okay, now rule number 9, perhaps the most important rule. Okay, I'll put a star on it because this is perhaps the most important rule, because if there's one rule that people mess up, it's this rule. Okay, so it's done in 2 parts. All right, rule number 9, I'll do it in 2 parts. So this is rule number 9, part 1. So what I'll do is I will write down an expression in surd form. Okay, and then we will write it down in index form, and then with the help of that we will come up with a rule. Okay, that's how I like to do this rule: surd form, index form. Transformation and vector. I think I do have transformation and vector in my to-do list. I've done surds. I've covered surds from scratch. I don't know were you guys sleeping or what. I've covered surds, exponential growth, and recurring decimal to fraction, I think last week only. Okay. So here we have square root of a. Now what is square root of a when we write it in index form? It's a power half. Now why is it a power half? It's because the power on a is 1, and when we say square root, okay, it's basically the second root that we're taking. Okay, the power outside the root is 2. Then if let's say we have cube root of a. So we have a and we're taking its cube root. So what is this when we write it in index form? This is basically a raised to the power 1 upon 3. Okay, similarly, if let's say there is a and we are taking its 4th root, what is this when written in index form? It's a to the power 1 upon 4. Okay. So what we do is we generalize this and we say that if you are taking the nth root of a, you can write this in index form by simply writing it as a raised to the power 1 upon n. Okay, so this is the rule. Okay, now let's do part 2, and this rule will, if you don't get it right now, that's fine. When we do it with actual values, then things will start to make a lot more sense. Okay, so please don't panic immediately. Just hold it, take it easy, you'll understand once we do some examples. Okay, so if let's say you have a raised to the power 2, and suppose you're taking the cube root of it, how will you write this in index form? This will be a raised to the power 2 upon 3. So you guys can probably identify a pattern now that the power that's inside is the numerator, the power that's outside is the denominator. Okay, it's like in out. The power that's inside is in the numerator, the power that's outside is in the denominator when we're writing it in index form. Okay. If let's say you have a raised to the power 3 and let's suppose you are taking the square root of it. Okay. So how will you write this in index form? It's going to be a raised to the power 3 upon 2. If let's say you have a raised to the power of 5 and you are taking its fourth root, how will you write this in index form? It's going to be a raised to the power 5 upon 4. So we generalize this and we say that if you have a power m and you happen to be taking its nth root, this will be written as a power m over n. So the two rules, these are the two rules. Okay, so these are two very important rules that I was talking about. Okay, rule number 9 part 1 and rule number 9 part 2. Okay, now let's use some actual values. Okay, now somebody asked, I should answer that question. Somebody asked that when will I stream intersecting circles? So I'll most likely do that on Monday. Okay, on Monday I'll do add maths, and then maybe on Tuesday or Wednesday I'll do math. Okay. Anyway, so let's put these rules to the test. Let's do some examples where we have to use these rules. So let's say that you are asked to evaluate. Once again, with questions like these also, you will be asked to evaluate. Let's say you're asked to evaluate 8 raised to the power 1 upon 3. Now, the way it's written, some of you may be able to figure out exactly what you have to do. I can't, so I would prefer writing it in surd form. So when I write 8 raised to the power 1 upon 3 in surd form, this tells me that I need to take cube root of it. And what's the cube root of 8? That's equal to 2. Okay. Yes, intersecting circle is part of add maths. Let's say that you are asked to evaluate 9 raised to the power 1 upon 2. Now, if you know what 9 raised to the power 1 upon 2 is, that's brilliant, but I would prefer to write it in surd form. So 9 raised to the power 1 upon 2 basically means that we're taking its square root, which is equal to 3. Okay. Let's do some more examples. Let's say you're given 64 raised to the power 1 upon 3. Now 64 to the power 1 upon 3 means that it's 64 to the power 1 and we're taking its cube root. So what's the cube root of 64? Ideally you guys should know, I'll write this on the side, that ideally you guys should know 1 to 20 squares. Okay, 1 se leke 20 tak you should have all the squares memorized, and ideally you should have all the cubes memorized from 1 to 10. Okay, ideally. This doesn't mean that if you don't have them memorized, it's the end of the world. It's not. You can always work it out there and then, but you will end up wasting a lot of time. Okay, a lot of precious time. So cube root of 64 is equal to 4. Now let's do some complex examples. Let's say that you have 9 raised to the power 3 upon 2. Now if you know the answer to this, that's brilliant. But if you don't, if you're like me and you don't know the answer and you prefer doing it step by step, then here's how you would do it. So 9 to the power 3 upon 2 is best evaluated when written in surd form. Okay, so this means that it's 9 cube that we're taking the square root of. Now, if you know 9 cube, that's great. I don't know what the cube of 9 is, even though I just asked you guys to have, actually I do know what the cube of 9 is, but I don't know what its square root is going to be. Okay, so instead of taking the cube of 9 first and then taking its square root, I'm going to change the order. I would prefer to make the number smaller by taking its square root. Okay, so I would prefer that I take the square root first. So the square root of 9 is 3. And then since it's a smaller number, taking the cube of a smaller number is much easier. So 3 cube equals to 27. And there you go. That's the answer. Job done. Okay, let's do another example. If you got it, that's great. If you didn't, nothing to worry about. We're going to do plenty of examples. Let's say we have 64 raised to the power 2 upon 3. This means that we have to square 64 and take the cube root of it. Now, once again, if you're smart, you would know. Actually, you don't have to be smart to know what the square of 64. I mean, you'd have to be extremely smart to be able to evaluate what the square of 64 is immediately, but I can't do that. So what I would prefer is, I would prefer that I take the cube root of 64, because that way I would be dealing with a smaller number and the cube root of 64 is 4, and squaring a smaller number is much easier 4 squared is equal to 16. Okay? So I'll give you guys some examples to solve, see if you can do it. Figure out 27 raised to the power 2 upon 3 for me. Figure out 25 raised to the power 3 upon 2. Figure out, okay, let me think. 8 raised to the power 4 upon 3. Yeah, work these out. Work these out and then we'll do some fractions also. Sir, variation, algebraic fractions of algebraic expression, linear inequalities, numbers, simultaneous equations, expansion, factorization. Oh, okay. I've already covered simultaneous equations. I've already covered quadratic equations. I mean, doesn't mean that I'm not going to do them again, but I'm just saying if it's like super urgent, you can watch them on my channel right now. Otherwise, you'll have to wait. Linear inequalities I will probably do very soon, especially the graphs part. And what else? Yeah, I will be streaming mensuration very soon. Composite functions. Oh yeah, composite functions has also been added recently, right? Yeah. Questions that require to show the quadratic. Yeah, I have done that, but chalo, I'll do it again. Yeah, Ice Cream Man is back. Is there any idea why they changed AdMaths V1? Any idea why? I don't know. They probably felt like, they probably woke up and thought, how can we make students' life more miserable? And somebody probably suggested that. He probably ended up getting a raise. It's not winter where I am. The AC is on, the fan is on. So anyway, so the answer 9, yes, that's correct. Good job. This is 9. 25 raised to the power 3 upon 2. This is 125. Good job. 8 raised to the power 4 upon 3. Okay, I don't think you guys gave me the answer to that. 8 raised to the power 4 upon 3. $16. Yeah, that's correct. 16. Good job. Okay, so we have done 9 rules, just a few more rules, and then we'll do some example questions. Acha, before I do rule number 10, which is going to be the last rule, Sarah's mathematics. Yes, I do. Like I said, I do plan on doing more streams this year, inshallah. So sit tight. Hopefully, by the end of the session, I would have the entire syllabus. Okay. All right. Now, rule number 10. But like I said, before I do rule number 10, let me just do some more examples. Okay. So these are some miscellaneous examples. Okay. In fact, let's just continue the previous ones. Okay. So part I. Let's say you have 64 over 9, which is being raised to the power of 1 upon 2. Okay, 64 over 9 raised to the power of 1 upon 2. So what does 1 upon 2 mean? Let's write it in third form. So when we write it in third form, we realize that it's square root. Okay, and what's the square root of 64? That's 8. What's the square root of 9? That's 3. Okay, so that was part I. Let's do more questions. Let's say you have to evaluate the following. 9 upon 16 raised to the power minus 1 upon 2. No, I don't do further maths. I don't teach further maths. Now, before I can figure out what 9 upon 16 raised to the power minus half is, I have to make sure that the power is positive. So for that, I will take the reciprocal, raised to the power of 1 upon 2. And 16 over 9 raised to the power 1 upon 2 basically means that we are taking the square root of 16 and 9, which is equal to 4 upon 3. There you go. That's correct. Good job, Ibrahim. Now part, no wait, A, B, C, D, F, G, H, I, J, K. Okay, I forgot my ABC. So let's say we have 64 over 27 raised to the power of minus 2 upon 3. Okay. Now please don't jump to conclusions with questions like these. I know students like doing that, but it's never a good idea because these are 1 or 2 mark questions which you can get for sure. I mean, these are these can be guaranteed marks given that you guys don't jump to conclusions. So first things first, we cannot evaluate a negative power, we make it positive, and in the process, when we make the power positive, we have to take the reciprocal. So this becomes 27 upon 64 raised to the power of 2 upon 3. Now what does raised to the power 2 upon 3 mean? That means that we're cubing the entire thing, and we're taking the square of the entire thing and we're taking the cube root of it. Okay, so what's better, that we square first or take the cube root? Obviously it's better that we take the cube root first. So the cube root of 27 is 3, the cube root of 64 is 4, and now we still have to square it. So what do we get? We get 9 upon 16, and that's the final answer. Alright fellas, so now let's do rule number 10, the last and the final rule. Okay, and after that we'll do past paper questions. Okay, so let's say rule number 10 is more like a fact. Okay, if let's say you have a power m, which is equal to a power n, okay, then m is equal to n. Okay, and what's the purpose of this rule? This is used in solving exponential equations. Okay, this is used in solving exponential equations. For example, let's say you have 2 power x, which is equal to 8. Now before I can solve this, I'll have to make sure that bases on both sides are the same. So can I rewrite 8 as a power of 2? Yes, I can. That's why they've given you such a question, so that you can change the bases. Now what's the purpose of writing it as a power of 2? So that a lot of people say that, oh, you can cancel the bases. Now we're not cancelling anything. Okay, what we're doing is we're just ignoring the bases because they're the same. There's nothing to evaluate from that, and we're comparing the powers so that we are able to find out the value of x, which is equal to 3. Okay, let's do another question. Let's say you are given 4 power x, which is equal to 1 upon 16. Now there is a connection between 4 and 16. It's no coincidence that you're given 4 on one side and 16 on the other. That's because they are related. But what is it that you have to do? You have to first make sure that bases on both sides are the same, and not only the same, but they're both in the numerator. So this is 4 power x upon 4 square. Now once we move 4 square in the numerator, what happens is the power becomes negative. And why have we done this? So that we can ignore the bases and compare the powers. So what do we have? We have the value of x, which is equal to -2. Yes, Amna, the exponential growth lecture is uploaded on YouTube. I did a live stream recently only. You can check it out. So, Ibrahim, even if this was A-level math, I would still not suggest that you use logs. I mean, why do you have... You can, but there's no point if you can solve it without logs. Okay, let's say we have 4 power x equals to 8. See if you guys can solve this. 3, I'm afraid 3 is not the correct answer. 3 upon 2. Yes, AI daily facts. Your answer is correct. 3 upon 2. Okay, so the trick here is that you cannot write 4 as a power of 8. You can't write 8 as a power of 4. I mean, you can, but it's not easy for us to figure out because the power won't be an integer. However, what we can do is we can rewrite both 4 as well as 8 as powers of 2. Okay, now these two powers, 2 and x, get multiplied as we saw earlier. This becomes 2 to the power 2x, which is equal to 2 cubed. We ignore the bases so that we can compare the powers, and the value of x turns out to be 3 upon 2 or 1.5, however way you want to write it, it's up to you. It doesn't make a difference, okay? All right, let's do one more example before we do some past paper questions. Okay, in fact, this is a past paper question. 10 power x equals to 0.001. Okay, see if you guys can solve this. Wa alaikum assalam. Abdullah, 5 marks. 5 marks or maximum, I would say 6 marks. Okay, so let's solve this. Let's see. 0.001 we will have to write as -3 or -4. Okay, let's find out. So the thing is, don't immediately start worrying about indices, okay? Initially, this question has got nothing to do with indices, okay? Initially, what you have to do is you have to worry about converting this into fraction form. Okay, how do we convert this into fraction form? Let's write it separately. So 0.001, we'll have to multiply it by 1, 2, 3. We'll have to multiply it by 1,000. If you multiply the numerator by 1,000, we'll have to multiply the denominator by 1,000 also. So what are we looking at? We're looking at 1 upon 1,000, okay? On the left-hand side, things remain as it is. Now, can 1,000 be written as a power of 10? Can 1,000 be written as a power of 10? Yes, it can be. We can write 1,000 as 10 power 3, okay, which is equal to 10 power x. Now, let's take 10 power x in the numerator, or 10 power 3 in the numerator, so it's going to be 10 raised to the power minus 3. So the whole purpose of doing this was so that the bases on both sides can be the same, so that we can ignore them and simply focus on the powers, and we get x equals to minus 3, which is the correct answer. Those of you who are saying 10 minus 4, they've probably made a calculation error, but the thing is, you can't just say that, oh, I was close, I was just, my answer was just off by 1. Thing is, these will probably be 1 or 2 mark questions, so you want to make sure that you get them exactly right. Okay, not partially right, you want to make sure that you get them exactly right. Okay, so let's now open up the worksheet which I plan to solve with you guys. So I am going to hide my iPad screen for a minute. You guys can download the worksheet also, okay? I've attached the worksheet in the description. You'll find a link which will take you to the folder in which you can find the relevant worksheets. Just a minute. Let me sort out a few things. Okay, here we go. So this is the first worksheet. X equals to minus 4 is totally unacceptable. Well, it's wrong. So in math, your answer is either right or wrong, and there is nothing in between. Okay, so all these questions are non-calculator. Okay, so here is the first question. It's a slightly different question. It's not the kind of questions that we have solved. So it says a power x equals 5, and we have to find a to the power of 2x. Okay, how do we do this? Well, how about instead of writing a power 2x, instead of having a power 2x, I write it as a power x squared. Okay. Now we already know what a power x is. We know that this is equal to 5. Okay, because in multiplication you can change the order. That's fine. It makes no difference. Now a power x, as we know, is 5. So we square 5. What's that equal to? That's equal to 25. Okay. That's it. Job done. Now let's do part B. In part B, we cannot find a power minus x because we know what a power positive x is. So is there any way I can turn this to a power positive x? Yes, I can. All I have to do is take the reciprocal. Now we know that a power x is 5. So it's 1 upon 5. That's it. Okay. This is something that's given to us in the question. Okay. This is given to us, in case you're wondering. Okay. Now, part B. And I should mention that this is slightly incorrect. It's raised to the power of 1 upon 2. Okay. Now, question number 2, part A. It says evaluate 3 cubed minus 3 raised to the power of 0. So you can't really use a rule over here. It's a simple mental math question. 3 cubed is 27. 3 power 0 is 1. So 27 minus 1 is equal to 26. And there you go. That is the answer. Okay. Now, part B. How 5? What do you mean, how 5? Read the question. It says a power x equals to 5. You're given that. All you have to do is incorporate a power x in this so that you can replace it with 5. Okay. Now, let's do question number 2, part B. Okay. Pay close attention. Now, like I said, this power half is part of the question. There's a slight misprint. I don't know. Maybe this is not the updated version of the worksheet that I have. Just a second. Let me see if I can quickly get the updated version. Just a minute. Okay, just hold on a second, all right? Okay. Now part B. Let's see what part B says. Sorry about that. So 9a cube, b cube upon 16b, a power 5, the whole thing power 5. So first thing you need to do is this. Forget about this power for a minute. Focus on inside the bracket. Okay, focus on what's inside the bracket. So let's see how much it is that I can simplify while being inside the bracket. So 9 upon 16 will remain as it is. Okay. As far as a is concerned, so we have a power 3 divided by a power 5. That means a power 3 minus 5, which will be a power minus 2. So might as well write it as a power minus 2. Then we have b cube, which is being divided by b power 1. So that means that's equal to b square. And now do not forget the power 1 upon 2. Okay. Now, before we start evaluating this, here's what I would suggest. I would suggest that you simplify, you make the power inside the bracket positive first. So we'll let 9 upon 16 be as it is. We'll shift a square in the denominator, and in the numerator we still have b square. Okay, this is what we're taking the square root of. Okay, this is because this is what we're taking the square root of. Now 9 upon 16 if we take the square root of it, you can write it separately or you can do it directly. We've done enough practice now. So the square root of 9 is 3 and the square root of 16 is 4. Now what happens when you have b power half and you take the square root of it? Well, the powers simply get multiplied. Okay, so these two powers get multiplied. So half into 1, you can either write down the answer directly, or if you're not feeling too confident, then just add an extra layer of working. Same goes for a. 2 to the multiplied by half, because when you have a power raised to another power, the powers get multiplied. So we have 3b in the numerator and we have 4a in the denominator, and that's it. That's your final answer. Okay, so I hope it makes sense. Now let's move on to the next question. Evaluate. Once again, these are non-calculator questions, so make sure that you solve them accordingly. Now, 1 upon 3 raised to the power of 0, well, whatever is inside the bracket becomes irrelevant because it's being raised to the power of 0. So that means this is going to be 1 minus 1 upon 3 whole squared, which means minus 1 upon 9. Now this has become a normal math question, an arithmetic question. The LCM is going to be 9, so we multiply this by 9, we multiply this by 9, that's 9. We multiply this by 1 and 1 by 1, so that's 9 minus 1, which is equal to 8 over 9, and that is your final answer. There you go. Why would we take square root? Okay, I guess you joined late because we have power half, and power half means we're taking the square root. Okay? Put some thought into it. Why would I take the square root? I won't just take the square root because I feel like it. Because the power is half, that's why we're taking the square root. If the power was 1 upon 3, we would take the cube root. Okay? All right, question number 3, part B. Anyone who would like to give me the answer to 3, part B? X squared upon 3. Let me check. So first things first, we will make the power positive by taking the reciprocal of the fraction. So this is going to be x power 6 divided by 27, and now we can comfortably raise it to the power of 1 upon 3. So powers get multiplied. It's going to be x raised to the power 6 into 1 upon 3. As far as 27 raised to the power 1 upon 3 is concerned, that means you're taking the cube root of 27. So x squared divided by the cube root of 27, which is 3. So that's the answer, x squared upon 3. Good job, fellas. Okay, question number 4, fairly easy. But chalo, I'd still like you guys to do it. Eight. Are you sure about that? It's going to be 10. 9 plus 1, which is equal to 20. Okay, that's interesting. I'd like to know how you go. Okay. 10 is correct. All right, what about part B? Do part B. B, okay, I'll explain it again. So make the power positive by taking the reciprocal. X power 6 comes in the numerator, 27 comes in the denominator. Now when you have a power raised to another power, the powers get multiplied, and 27 is also raised to the power 1 upon 3, which basically means that you're taking the square root of cube root of 27, so which is 3. There you go. X power 6 into 1 upon 3 becomes x squared. Cube root of 27 becomes 3. Okay, so I'm going to solve part B. 4 can be written as 2 squared. N remains as it is. 2 power n minus 1 remain as it is. So we ignore the basis. We have 2n, which is equal to n minus 1, which means n is equals to minus 1. There you go. Good job. Whoever got the correct answer, n equals to minus 1. Okay, now I'm going to do some complicated questions. Okay, I'm going to skip the easy ones, focus more on the complicated ones. So this is easy, this is easy. I'm going to do part B. So we have 2 squared, which is being multiplied by 8 raised to the power 5 upon 3. And according to the question, we can write this as 2 power k. Okay, now how do I multiply these two? Well, we know that if we are to multiply, so what we have to do is we have to make sure that the bases are the same. Okay, how do we make bases the same? Here's what we can do. 2 squared multiplied by 8 can be rewritten as 2 cubed. The power 5 upon 3 remains as it is, which is equal to 2 power k. Now, This 3 and this 3 cancel. Why? Because we are doing 3 into 5 upon 3. Okay, so 3 and 3 cancel and we're left with 5. So we have 2 squared multiplied by 2 power 5, which according to the question is equals to 2 power k. Okay. So we have 2 power 7, which is equal to 2 power k, which means the value of k is equal to 7. There you go. There you go. Okay, that is the correct answer. Now part B. Part B. We have power minus half. So the first thing we have to worry about is fixing this minus half power, because for as long as it's negative, actually no, that's not the first thing we have to worry about. What we have to worry about is simplifying inside the bracket. Okay, let's simplify it inside the bracket. So this is going to be 9. Okay, there's nothing we can do with 9. And then we have x raised to the power 7 minus 5, which is equal to x raised to the power 2. And then we have y raised to the power of minus 8 to the power of minus half. Now here I would suggest that you guys use that rule. Okay, I would suggest that you guys use that rule where instead of doing y power 1 minus 9, you do y raised to the power 9 minus 1. Okay, so I'm going to redo this. Let's redo this. So we have 9, x raised to the power 7 minus 5. Now we shift this in the denominator. So that way we have y raised to the power 9 minus 1. And this whole thing is still being raised to the power minus 1 upon 2. Okay. Now we have 9 raised to the power 9x raised to the power of 2, or 9x squared, upon y raised to the power of 8, which is being raised to the power of minus 1 upon 2. Now how do we make the power positive? We make the power positive by taking the reciprocal. So it's going to be y power 8 over 9x squared, and this is what we are taking the square root of. So when there's a power which is raised to another power, the powers get multiplied. So that means 8 into half, that's going to be y power 4. Same goes for x squared into half, that would be simply x. And what about 9? 9 is being raised to the power of half, that means we'll take the square root of 9, which is equal to 3. So we have y power 4 upon 3x. Okay, this is the correct answer. Okay, did I miss anything? Thank you, I appreciate it, Shahab. Alright, I'm glad to have helped, Ahmed. Okay, next couple of questions are fairly easy. Let's skip them. 3D mensuration, inshallah, on either Tuesday or Wednesday. But I would like you guys to do question number 9. Okay, you guys, all the questions that I'm skipping, you guys can solve them later. Right now, I would like you guys to do question number 9. Transformation. I already have an entire playlist on transformation, by the way. I would suggest you guys go over that in case you haven't. But as far as stream is concerned, it's not a top priority. Vectors is, but I'll do paper 2 topics first. Okay, the important paper 2 topics such as mensuration, trigonometry, statistics first, quadratic equations also, algebraic word problems, and then maybe the rest of the topics. Okay. (8x raised to the power of minus 9). Let's see. X power 15. Okay, your answer is correct, but it's definitely not the simplified version. So here's what we have to do. First of all, let's simplify inside the bracket. So we'll let 2 be as it is, and we will take x squared in the denominator. So it's going to be x cube. Why am I taking x squared in the denominator? Why am I doing 5 minus 2 instead of 2 minus 5? That's because I don't like negative powers. Okay, nobody likes negative powers. Unless there is no option, that then you have to deal with them. But if you can avoid them, then why not? Okay, now before I further simplify this, we'll have to make the power positive, which means taking the reciprocal. So x cube upon 2 raised to the power of 3. This means x raised to the power 3 times 3, which is 9, upon 2 cube, which is 8. So x power 9 upon 8 is the final answer. Okay, so I would suggest you guys solve question number 10 also, and then we'll do the second worksheet, and then that's it. सर हमें कब तक सिलेबस ख़त्म करके ईयरली शुरू करना चाहिए? Keep 2 months for yearly past papers. And here's what I would suggest, because the shock that you get after starting yearly past papers is real, and it takes a while to build that momentum, to build that flow of solving yearly past papers. So here's what I would suggest. I would suggest don't wait till you finish the syllabus, because mentally you will never feel ready to start yearly past papers. Okay, you will never wake up one day and feel like, okay, today I'm ready to start yearly past papers. Aisa kabhi nahi hoga. So here's what I suggest. I suggest that you, once you're done with like 50%, 60% of the syllabus, throw in a yearly past paper here and there. Solve only questions of the topics that you have covered, not of the topics that you haven't done. This way you will sort of minimize the shock, basically. And to answer your question, 2 months, okay, in the last 2 months you should be solving yearly past papers. That's it. And side by side you should be doing topical past papers of the topics that you find yourself struggling in. That's it. Sir, past papers for your brain, best sleep is after doing paper 4 fully. Yeah, paper 4 is an exhausting paper. IGCSE paper 4 and O-level math paper 2, they're exhausting papers. So you want to make sure that you are fully prepared, you have slept well, you've eaten well, and obviously you've studied well. Okay, anyone who'd like to give me the answer? 8x power 6 is correct. 8x power 6 and 90 is correct. 8x power 6 and 90, these are correct answers. Good job, fellas. Okay, let's quickly do worksheet 2 also while we're at it. What do you guys suggest? It's a small topic, so might as well cover the entire thing. Okay, here's worksheet 2. This is all these questions are either from paper 2 or from paper 4. That means you can use a calculator. Yeah, there's always that. So that means you can use a calculator, but I don't think at any point you will really feel the need to use a calculator. Okay, I mean, there's nothing that you can do with the help of a calculator. Okay, unless you want to figure out what 2 square is or 2 cube is or what the cube root of 27 is, then yes. But other than that, you won't feel the need to. Okay, so this is easy. However, let's solve question number 2. I'd like you guys to do question number 2. सर आप अपने एक्सपीरियंस से बताएं क्या बेटा मैं उम्रे पे गया था, तब मैंने टेंट करवाई थी. ऐसे ही बैठे बैठे मुझे ख्याल नहीं आया टेंट करवाने का. एंड आई डोंट हैव द आंसर टू योर क्वेश्चन. मेरा दिमाग तो उतना ही चल रहा है. t cube upon t square equals to t. Wait, what question is that? Is that even a question? Acha, okay. Part, you're talking about the previous question. All right. 3b squared upon a. All right, let's check. So first things first, 9 remains as it is. We shift a in the denominator, so it becomes a square. We shift b square in the numerator, so it's 9b power 4 upon a square, raised to the power of 1 upon 2. 9 to the power 1 upon 2 is 3. B power 4 raised to the power 1 upon 2 is b square. A square raised to the power 1 upon 2 is simply a. Okay, so 3b squared upon a, that's the answer. Okay. Acha, this could be easy questions. I'm going to skip. I'd like you guys to do part 3 quickly. And while you're at it, do question 4 also. AdMath stream, inshallah, this Monday. Sir, can you please help us with the AdMath question? For your turns, how would be the question? So I am in the process of compiling questions, compiling non-calculator questions. Inshallah, I will be done with it during the winter break. I'm making non-calculator worksheets. Okay, so once I'm done with that, I'll share them. They will most likely be up on my website, and you guys can download from there. Sir, in question 6, S19. Okay, which one are you talking about? Okay, probably talking from the previous, or you're talking about the previous worksheet, I guess. Okay, so anyone who'd like to give me the answer to part 3? Okay, 9a upon... Okay, no, I think that's the answer to the previous part. 4y upon 3x power 4. Okay, let's check. So there's nothing we can do inside the bracket to simplify. So we will first take the reciprocal of it so that we can make the power positive. So 27x power 12 raised to the power of 1 upon 3. Now we have to take the cube root of everything one by one. So the cube root of 64 is 4. The cube root of 27 is 3. As far as y, which already has a power, is concerned, y cube into 1 upon 3 becomes simply y. X raised to the power 12 into 1 upon 3 becomes x power 4. So it's 4y upon 3x power 4. Okay. Can we write final answer as 1 upon x? I'm pretty sure you can't. You can't write the final answer like that. Okay, it should be as simplified as possible. M equals to 9. All right, let's check. When you cross multiply, the powers get added. So this becomes x power m plus minus 3. We ignore the bases because they're the same. M is equals to 9. You're right. Good job. Okay, now who can solve? If you guys can solve this question, that means you're really smart. Okay. Everything we've done on one side and this question on one side. If you can solve it, that is. Please cover map scales and sketching in your next diagram. Okay. Okay. In the next, let me tell you, my next stream will most likely be on mensuration. Okay. My next stream will most likely be on mensuration. And please, no peeking. Okay, I hope nobody saw the year end. Well, you can always go back and check. Well, don't get any ideas. Please change your pen. This one looks ugly. Okay. Maybe lessen up the flatness. Let's see if this helps. Sir, this AI topic of sketching curves in algebra and the graphs, is that the topic in which we have to match the equation to the graph? It's a bit of that, and it's a bit of graph sketching which has been added. Not added, it was actually always there. Now they are going to emphasize on it, I guess. AdMath stream, inshallah, on Monday. M1 stream, M1 and S1 streams, inshallah, after January, not before that. 2n equals to m. Are you sure about that? I don't think so. Okay, I don't remember the answer, but let's find out. So what can we do here? We can take 5 power n common. Okay, that's exactly what I'm going to do. I'm going to take 5 power n common. And then inside the bracket, we will have 1 plus 1 plus 1. Let's see how many times. So 1, 2, 3, 4, 5. So inside the bracket, we'll have 1 plus 1 plus 1 plus 1 plus 1. Okay, so basically we'll have 1 5 times. Okay, which is equal to 5 power m. Okay, now this becomes 5 power n into 5, which is equal to 5 power m. Now same bases are being multiplied, that means powers can be added. So this becomes 5 power n plus 1, which is equal to 5 power m. Now we cross out the bases and we have n plus 1, which is equal to m. Surprisingly, nobody gave the correct answer, which is kind of sad. And what are we supposed to do? We're supposed to find an expression for m in terms of n. So there you go, m is equals to n plus 1. I don't know what you guys were doing, but here's the correct answer. Easy peasy. Well, you still got it wrong. Actually, you got it right. Okay. Good job, Yusuf. Okay, whoever. Yeah, you did. I take my words back. Good job. Okay, last set of questions. I'd like you guys to do. I would like you guys. Yeah, okay. मान लिया भाई. I'd like you guys to do 6 part 3 and 7 part 2, and that's it. Sets and functions. Sets and functions. Okay. Let's start with mensuration. Okay, I know you guys probably want me to cover the entire syllabus, even the topics that I have already covered, but let's start with mensuration next, which I'll most likely do either on Tuesday or on Wednesday. I plan on doing back-to-back streams, so Monday is add maths, Tuesday most likely will be math again, and then maybe A-level math. Do you specialize in Edexcel, GCSE Math? I don't specialize in it. I have taught it, but I don't specialize in it. Do 6 part 3 and 7 part 2. Okay, sorry, I thought I circled it. 6 part 3 and 7 part 2. Yes, I got a haircut. It's it's been a while. Actually, I went for Umrah actually. That's where I got a haircut. Sir, if you could make one video on kinematics math if possible. Okay, let's check. Let's see if I can. Like I said, I'll start with mensuration, and then we'll do some more paper 2 topics, and then we'll take it from there. Hairline. What about my hairline? It's receding. Sir, which topics are you going to do this year for Add Math? I will inshallah cover all the important topics. Okay. All right, part 3. Anyone would like to give me the answer to part 3? Let's check. First things first, anything we can simplify? No, we can't. So let's take the reciprocal. 64 upon 27 x power 9 y raised to the power 27. This is being raised to the power 1 upon 3. So the cube root of 64 is 4. In the denominator is where everything's going on. Cube root of 27 is 3. Y power 9 to the power 1 upon 3 is x power 9 to the power 1 upon 3 is x cube. 27 raised to the power 1 upon 3 is 9. There you go. Okay, now quickly do 7 part 2. In fact, I'll just solve it. So first things first, we make the power positive by taking the reciprocal. So x power 16, y power 8 divided by 16 raised to the power 3 upon 2. Okay, now 16 into 3, that's 48. Yeah, 48 upon 2 is 24. So x power 24. 8 into 3 is 24. 24 divided by 2 is 12. In case you're wondering what I'm doing, here's what I'm doing. X power 16 into 3 upon 2 and y raised to the power 8 into 3 upon 2. Okay. And then 16 raised to the power 3 upon 2 basically means 16 cube and we're taking the square root of it. So 16 cubed, we don't know what it is, but we do know what square root of 16 is, that's 4, and we do know what the cube of 4 is, which is 64. So the final answer is x power 24, y power 12 divided by 64. That's the final answer. There you go. Divide upon 64, yes. Okay, so this is it. I will stop here. We are done with indices. Now, all the questions that I've skipped, I would encourage you guys to practice them. And I've shared the answers also, so you guys can check. You don't really need anyone's help. So I'll stop here. Inshallah, on Monday, I'll be streaming Add Maths. I'll be covering intersecting circles. It'll probably be an hour long, not more than that. And I'll do some past paper questions alongside. And then on Tuesday or on Wednesday, inshallah, I will be doing mensuration. Okay, so that's it, fellas. Take care. See you on Monday. Have a nice weekend. Allah Hafiz.